Hi friends, today we're gonna do the lab 3.2 in Amazon SageMaker, and let's start. Uh, in this lab uh, we are gonna detect an normal and abnormal case. I mean it's a binary case, and we have six attributes, which is pelvic instance, pelvic tilt, as you can see, and the rest of them. And we have obtained this data set from this URL. It's an, I think it's an, yeah, Edu. So Edu. So it's an university URL. And now let's start the lab step. First of all, we will import the data. For importing data, we will import first these libraries, and also pandas library and this library. And then in this code block in here, as I mentioned the last lab, we request the zip file from this URL, and we extract this zip file. Let me run these blocks. I think it's done. I can see the files. Yeah, so it's shown in here. Yeah, as I mentioned earlier, this file is containing the data. The data has six attributes and one string class, which is abnormal or normal. Now we will continue. We can get the top data with using this with converting it to pandas data frame, and we can let me run this block. So I should run all of them. Yeah, now it will run. So it gives the information about our data. It says there are 310 samples, and the data has 7 columns, which I mentioned, 6 attributes and 1 the class, normal or abnormal. Let's now run this. Yeah, and so you can see the contents of the columns. These are the our attributes, and this is the normal or abnormal, as I mentioned. It's an object. Now we can run that. So it gives the data types. For the attributes, it is float, and for the class, it's an object. Now we will run this block. So it gives information about the data, max and mean values, standard deviation, etc. Now let me run this. Yeah, so it's described the data here for all of them. It gives mean for pelvic instance, standard deviation, and mean and minimum and maximum values, as you can see. Now we will plot the graph. Yeah, it needs the plots, so I should maybe, yeah, it works now. So as you can see, the data shown here, and for example for the degree spondylosis, the maximum value is 418. So as you can see, it's shown in here. Like, you can see this graph as this table as a graph in here. And let me continue from the next block. So now as shown, for example, it's shown in the 0. It is the range, it's between 0 and 100. Also, you can see from there. Actually, it's hard to see from there, but you can see from there the minimum. Yeah, it should be here. It's not actually a 0. It's like around 25. It should be. What is this FBS pelvic instance? So pelvic, yeah, here. The minimum value is 26, and the maximum value is about 130s. So you can see here, actually it could be an outlier. And also there's an outlier in degrees spondylosis, whatever. Yeah, you can see, to determine the outliers. You can look at standard deviation, which is the if the standard deviation is high, it means that the minimum and maximum values are the between ranges. Minimum and maximum values are so high than the others. So in here, that curve, that little curve, is belongs on outliers. Yeah, we can visualize the data with his histogram, as I mentioned. For that, let me run. Yeah, as you can see, there's a little curve in here. Now continue from here, we can plot the histogram. The outliers, as you can see, the outliers is shown in here. We can plot the plot box. Yeah, the plot box is looks like here. And now we will continue from there. We will run. So we have 210 abnormal cases and 100 normal cases in our data. It's actually written here. And for the next cell, we're gonna continue. Actually, what was this doing? I don't remember. Just run it and learn. is it round? Yeah, I don't know actually what was this doing. As snapper. Actually, it could be turning these cases. For abnormal, it will return 1, and for normal cases, it will return 0. As I mentioned, this is a binary classification, so it did what I said. Now, when we plot, it will be the normal cases will be shown as 0, and the abnormal cases shown as 1. Let me show you. Yeah, as you can see, for this attribute in here, uh, to around actually it could be 50s to around 50s, uh, the uh, the class could be normal or abnormal, but after 50s this might be the in an abnormal case, because there is no normal cases in here. So we can say that after 50 the samples should be the abnormal case. So yeah, so there could be a correlation, because we know that after 50s there is no way to be a normal case. Yeah, now we will do the same approach for the other attributes. Now, as you can see, we did this plot box we did earlier. This is a plot box for the normal cases, and this plot box is the abnormal cases. So we need to catch another indicator to determine that class is abnormal or normal. So this is a good indicator. This attributes we have already did, and there are some other attributes could be good. For example, I think for example, sacral slope is not a good indicator because it looks like same. If I'm not wrong, we need to check these are with more sensitively. So let me continue from the lab. Oh yeah, we can check. We can sort the values. So that means that if it approximates 0, it means that it will be much less correlated from the class. So the sacral slope which I have mentioned is the less correlated with this class indicator, for a being class indicator. Now let me continue from this box. Yeah, these boxes actually give an information about the correlation between the attributes and also with the class. For example, yeah, if we look this attribute or this attribute, it could be, for example, if we can say that pelvic incidence, when the pelvic incidence is increasing, the sacral slope also need to be increasing. you can inference from the data from this graph. And as you can see in here, sacral slope is overlapped to each other. I mean, there is almost nothing changed from upper and the lower part. When you look at the degrees of analysis, it is very clear too. After that point, it needs to be an abnormal case 1. So what was the second correlated data? It should be not this one. Yeah, pelvic instance. When you look at the pelvic instance, where is pelvic instance? Yeah, it's here. When the data after 75s, I think it goes like discrete, but in here it goes like the continuous. So if it is higher than the 75s, it probably needs to be abnormal cases. This is the second most correlated attribute to determine it's abnormal or normal. Now we will continue from this block. Yeah, it's a heat map, I think, if I'm not wrong. Is it written? Not written. When it's being much correlated, it will becomes more green, and if it's not so much correlated, for example with pelvic radius and the pelvic instance, there is no good correlation. If you look at the this graph, actually, what was the attributes? Pelvic tilt and the pelvic tilt, and we can do this for pelvic tilt and pelvic radius as well. For example, if you look pelvic radius and pelvic tilt, yeah, pelvic radius in here, pelvic tilt, it's spread out. The dots in the graph are spread out all the way, but if there is a correlation, it needs to assemble in a way. It could be like that, or anything, but it needs to be more assembled way, more closer to each other. It shows the correlation. We can see in here the class, the abnormal and normal cases. For degrees of analysis, there is a high correlation. We can say the most higher correlation is this attribute, and after that the pelvic instance is a good attribute. When you look at here, you can see as well, and it shows like that. So actually that's the end of lab, and thank you for listening me. See you in the next lab.